All right, so it says Dan uses a remote control to make his drone take off from the ground. The function h represents the height in feet, and the feet in feet of the drone t seconds after it begins flying. And so we have this equation here. It says, which statement describes the situation? Well, there's a lot of information here, but in this particular problem, I'm just going to graph it. So turn your calculators on, and, oops, I guess that's all I got. And what we're going to do is I'll zoom in on my screen so you can see it a little better. I'm just going to hit clear and clear everything out. So hit the clear button. Are you guys getting familiar with where all the buttons are? I've got a big poster here, and then I got it on the screen too. But if you ever get to a point where you're like, I can't find the button, you can just raise your hand and say, where's the button or whatever. I'll pause the video. It's fine. It's more important to me that you know what you're doing with the calculators. There's a learning curve on this, okay? So I want to help you guys learn that. So anyways, we're going to graph this. So I'm going to hit y equals, and then I'm going to clear that out. That was from yesterday. Now, this is a minus sign and negative sign are different things in the calculator. This is technically negative 16. So if I hit minus 16, it won't work. I have to hit the negative button, which is down here. Then you know that you've hit the correct button because the negative sign is just a little bit shorter than the minus sign. From a high school mathematical perspective, there really isn't that much difference, technically. But I guess at the college level where they're a little more formal, they'd be real picky about that. But your calculator wants this first one to be negative. So I'm going to say negative 16, start my parentheses. I can't put t, I'm going to put x, it doesn't matter. Minus, now we use the minus sign. See how the minus sign is a little bit lower and longer than the negative sign? Okay, then I'm going to hit 2, close my parentheses, raise that to the second power, and then hit my right cursor to get out of that, and then I'm going to say plus 64. Now, this might not fit on my graph, so I'm going to hit graph. Okay, it sort of fits, but I don't like it. What are some options to zoom in or zoom out on this? What's the first thing you guys think of? We could hit the zoom button, and maybe we could do scroll down to zoom fit. I always start there because it takes the guesswork out of it. So I hit zoom fit. That's not bad. It doesn't have the whole thing. So from here, maybe I can zoom out just a little bit. So if you hit zoom and I zoom out just a little bit, let's see what that does. Now it asks me where I want to move the cursor. I'm going to put the cursor towards the middle of the graph like this. Maybe closer to the top. And then hit enter, and that's kind of the center of where it zooms out. Okay? So I'm okay with this. I'm not going to make a big deal out of it. So now I'm looking at the graph, and then it tells me, well, first of all, what does this graph represent? So let's go back and reread the question. And I'm just going to leave that there for a second. It says, Dan uses the remote control to make his drone take off from the ground. Function h represents the height in feet of the drone t seconds after it begins flying. So the graph, the y values of the graph represent the height of the drone. Then it says, which statement is true? The drone is on the ground from 2 to 4 seconds. B, the drone is on the ground from 0 to 16 seconds. C, the drone is on the ground from 0 to 2 seconds. D, the drone is on the ground from 0 to 4 seconds. What's the height of the drone when it's on the ground? 0. So what they really want to know is, when does y equal 0? What's another word? What are the zeros of a function? Does anybody remember what the zeros of a function are? Well, remember that the zeros of a function, in other words, they want to know when this thing equals 0. What value of t makes this thing equal 0? Well, we could do this in the graph, or we could do this mathematically. I could, I suppose, subtract 64 from both sides. Okay. And then I get negative 64. Whoops. Negative 64 is equal to negative 16 times the quantity t minus 2 squared. Now what do I do? Remember, we're solving for t. I'm going to divide both sides by negative 16. Okay? So when I do that, the 16s cancel. What's 64 divided by 16? 4. Positive 4, right? When you divide a negative by a negative, you get a positive 4. And so then this becomes t minus 2 squared. Okay. Well, that's the same as this, right? Is that right? Now, I forgot that I'm going to need this to equal 0. I really kind of screwed up. So what I'm going to have to do is get this. In order to find the 0, I can't solve this unless I set this to 0. So I'm going to have to well, there's two choices, right? We're lucky in the sense that I could figure out this problem. I need two numbers that when I multiply them, they equal 4. And I can only think of those two numbers like this. In other words, 2 times 2 equals 4, and 4 times 1 equals 4. So that means that my factors, t minus 2 has to equal 2, right? This has to equal this. Or it could equal 1 as well. Or t minus 2 oh, you know what? I'm going to back up. I was sitting here trying to figure out how to solve this, but there's actually an easier way to solve it. So let's do this. Erase this. I thought I had to set it equal to 0, but it's first thing in the morning. First problem of the day. So from this line down, we're just going to erase this. Now, what I realized was I was taking the wrong approach. There's more than one way to solve this, and I was taking the wrong approach. 4 is a perfect square. So what, and I have a square over here, so I could do this. I could take the square root of 4, and I could take the square root of this. So what that means, remember that when you take the square root, you have a plus or a minus 2 is equal to t minus 2, okay? Now, the reason for that is if I say 2 squared, that's just 2 times 2 equals 4, right? Or if I say negative 2 squared, then I have negative 2 times a negative 2, and that's equal to a positive 4 as well. So these are two solutions to the square root of 4. So now I just got to solve for t. I solve for t by adding 2 to both sides. So here's the tricky thing about that. I technically have 2 plus or minus 2 equals t. So that could be written two ways. I could say 2 plus 2 equals t, or, which is 4, or I could say 2 minus 2 equals t, which equals 0. So that means my zeros are, and remember, zeros is another word for x-intercepts. Those occur when y equals 0. They occur when t equals 0 and t equals 4. What does t represent? Time in seconds, right? How do I remember that? I got to go back. We'll reread the problem. It says Dan uses the remote control to make his drone take off from the ground. The function h represents the height, so h is the height in feet, and the drone is t seconds after it begins to fly. Well, I did this mathematically just to show you the relationship of the equation and how to get the numbers. So when does it equal 0? At 0 and 4 seconds. But I did a lot of algebra, and I already knew that. You want to know how I knew that? Watch this. When are the x-intercepts? Well, if I look at my graph, they're here and here. If I go to my table of values, everybody turn on your calculators and hit second graph. If you go up to 0, when x equals 0, what does y equal? 0. When x equals 4, what does y equal? 0. When x equals 2, this is the vertex, what does y equal? 64. So those 4 points are very important. In fact, I'm gonna take a screenshot here of these two things and leave them in your notes. So when I take a screenshot and put it on the slide, that's because I want you to sketch it. Now we're taking a lot of time explaining and re-explaining these concepts. We have to, because I really want it to sink in, because it's kind of hard, and it comes up again in Algebra 2. I really want to make sure that you understand everything. Everything. So let's look at that again real quick, and then we'll unpack it. All right. Let me slide these up here. So sketch this graph. Just kind of make it look like this. But the important parts of this is this right here and this right here. Where do those occur? This occurs at the origin 0, 0. So that's 0 seconds and 0 feet. Over here, this occurs at 4, 0. Now remember, that means at 4 seconds, it's 0 feet. At 2 seconds, it reaches its maximum height of 64 feet, right? So how do I know it's a max? Well, that's the vertex, okay? So again, We can double check that on our table of values. That's where those numbers come from. And we could check it from the graph, and we solved it algebraically. So what we did is we solved this problem 3 ways. We looked at the graph, so we solved it graphically. We looked at the data, so we used what we call a analytical or tabular approach. We used a table. And then we solved the equation, so that's an algebraic approach, okay? All 3 match up, all 3 line up, so I definitely have the right answer. Are there any questions?